Hello and welcome to Naptime Videos. My name is Aviva and today you will be learning about synaptic transmission. Alright, let's get started. Synaptic transmission is the process by which a neuron communicates across a synapse with a target cell, which typically is another neuron. This communication is done through the release of neurotransmitters into the synaptic cleft from the presynaptic neuron. Recall that neurons communicate with one another through action potentials, which are electrical signals that are generated in response to specific stimuli. Once an action potential is generated in the spike initiation zone of a neuron, it causes subsequent action potentials to be generated. So what happens when an action potential reaches the axon terminal? The axon terminals of neurons have what's called voltage-gated calcium channels. There's a lot of positively charged calcium outside of a neuronal membrane that wants to go inside of the cell. When the action potential reaches the axon terminals, voltage-gated calcium channels open and calcium ions enter into the axon terminal. Inside the axon terminal are vesicles filled with some kind of neurotransmitter such as serotonin or dopamine, which are docked at the synapse by docking proteins. The calcium binds to the docking proteins, which cause the proteins to pull the neurotransmitter-filled vesicles closer and closer to the axon terminal's neuronal membrane. The vesicles then fuse with the membrane and exocytose neurotransmitters into the synaptic cleft. At this point, the electrical signals of the action potentials have been converted to chemical signals in the form of neurotransmitters. Now in the synaptic cleft, the neurotransmitters bind to the receptors on the target cell, such as a postsynaptic neuron. After the neurotransmitters bind to the receptors on the postsynaptic neuron, the receptors become activated and typically either excite or inhibit the postsynaptic neuron. If the postsynaptic neuron becomes excited, it will likely generate another action potential, and the whole communication process will continue. If the postsynaptic cell is inhibited, it will not generate an action potential and the communication is halted. After the chemical message is conveyed to the postsynaptic cell, the neurotransmitters unbind from the receptors. Neurotransmitters are then either taken back up into the presynaptic cell in a process called reuptake, degraded by enzymes, or diffused out of the synaptic cleft. The removal of neurotransmitters from the synaptic cleft ends the process of synaptic transmission.